Hello, everyone. Hello, everyone. Welcome. Thanks for joining. We'll give it just about 1 minute before we get started. Give everyone a moment to click in, check their audio and video here, starting in about 1 minute. Thanks for joining, everyone. Giving it just another 30 seconds here as folks trickle in before we get started. If you can hear my voice now and you can see a screen, then you're ready to enjoy. Perfect. All right, looks like most of the folks have made it in through the front door. Thanks everyone for joining us today. My name's Evan Wimpy. I'll be your host and moderator for today's exciting webinar as we go through a comprehensive analysis and benchmarking of two of the most popular open source packages for media mix modeling. It's great these have been available for a while to folks, but now we'll do a really deep dive on how you can make some technical comparison between the two to decide which is best for you. And we're very lucky to have the folks on the call here to discuss this deep technical work today. Before we get started, a quick couple of admin notes. First of all, this is recorded. It will be available to you afterwards. So if you miss anything or want to go back and review, don't worry, it'll be there. It is available to you. There's a Q&A functionality for those of you on the webinar. So if you just click the Q&A, you can type in a question at any point that you have. We'll try to do our best to answer questions via chat during the presentation, which will be about 45 minutes. But then we'll try to save the last 15 minutes or so for live Q&A. So if you have questions, put them right there in the Q&A section, and the team will answer, and we'll try to get to those as best we can. There's also a vote functionality. So if you see a question that you really like and you want to make sure it gets addressed, then just upvote that so we will be able to see it. If your question doesn't get answered here, or you think of a question after the webinar is over, I will direct you to a Bayesian modeling Discord server where the conversation is active. You're welcome to come in, chime in there about PyMC-Marketing versus Meridian, about the webinar, or about anything Bayesian modeling. I'll put that Discord link in the chat here in just a moment. And now I'll hand it over to the fantastic team that's put this benchmark together, starting with Dr. Luca Fiaschi, and then handing it over to our two data scientists that did this technical work, Jake Pekarski and Teemu Salyanoja. Team, thanks so much. Luca, take it away.
Hello, everyone, and thank you for joining us today. My name is Luca Fiaschi. I'm a partner at PyMC Labs, and I've been one of the contributors in PyMC-Marketing, and together with Teemu and Jake on the call, one of the authors of this benchmark. Now we have an action-packed agenda. So if you go to the next slides, we're going to talk a little bit about why we are doing these comparisons, how we generated the data that's used in the comparisons, some of the results that are really technical, and the things we uncovered by doing this exercise, and wrapping up with some key learnings and recommendations for you as data scientists on which tool should you use, how and when. So taking it from the top, why are we making this comparison? I just wanted to remind everyone, if you go to the next slide, Jake, that Bayesian media mix modeling is becoming de facto the standard in the industry for marketing measurements. And there are multiple vendors overall that are implementing this technique. The two open source libraries that are the most used right now are PyMC-Marketing, which is built by our team and is based on the open source framework PyMC, and Meridian, which is built by the Google team and is TensorFlow based. There are a lot of very, very insightful but relatively high level guides in the internet that tell you by looking at the preliminary feature assessment, some comparison between the two libraries and which one should you use and when. However, so far we couldn't find a really deep technical evaluations of the bones of these two libraries, how really they compare based on reconstruction error, which is if you know the channel media incrementality, how closer you get can you get to the right signal? And regarding technical implementation details that really matter in real world, like the sampling speed and the robustness of the sampler. And so our goal here was to create a benchmark that is more as fair as possible. As of course, there are assumptions that goes into this work, but we make it open source to the community because we want something that's as fair as possible and can help the developers of both libraries evolve their framework and become better. And also something that's quantitative and not high level, but really goes into the details. So bear with us because this is going to really be an in-detail evaluation of the two frameworks. And there are a lot of details that get into it once you get into the hoods. So if you go next, just to frame a little bit about these library adoptions and the high level first. If you look at these two graphs, you have the number of downloads for PyMC-Marketing and Meridian on PyPy, and two other frameworks, which are Robin and Orbit. Now, Robin is a library that doesn't implement the Bayesian method. This is a technique that comes from machine learning for assessing incrementality. It's actually very much used in the industry. However, most of the teams that adopt Robin tend to be R users, and therefore the number of downloads on PyPy of the version that's in the Python version actually doesn't show up. And generally speaking, we know that the Python community is larger than for data science is larger than the R community. So I would say it's safe to assumption that the adoption of Robin is a little bit lower than the two others combined. PyMC-Marketing has been in the industry for way longer than Meridian. It has doubled the adoption than in terms of downloads than Meridian on a daily basis. So it is, I would say, safely assumed that is currently the incumbent library for building media mix model and the most adopted by number of downloads. So if you go to the next slide, if you look at actually implementation here, so you have two Hello World implementations of the two libraries. They both implement very similar models. In fact, PyMC-Marketing and Meridian are based on a seminal paper from some Google researchers that was published a few years back, where they introduced this concept of media mix models using Bayesian methods. And they look also very similar in terms of Hello World code. Of course, there is a little bit more boilerplates on the right libraries, but generally speaking, they both implement what we call the sklearn type of interface, where you have a fit method and a predict method, and you have objects that encapsulate these models. The differences between the two libraries are really gonna be in so some of the features that they support for like syntactic sugars to get to some results, and in the low-level implementation details of how they call the solvers and the sampling processes that they utilize in the backend. So that's what we will focus on. So if you go next. Here you see the high-level comparison regarding the features. So if you go scroll down a little bit, you will see that both libraries are relatively similar in terms of feature set. They both, and please note that because it's kind of misleading in some of the blogs that we have seen online, there is some kind of misunderstanding around this. They both implement time-varying intercept. They both implement the ability to create hierarchical media mix models with geographies and brands. And in fact, this benchmark focuses exactly on creating a complex hierarchical media mix models with geographies in mind. They both allow for lift test calibrations. They're both very well written and unit tested libraries. They both have integration with MLflow, and they both provide a GPU sampling accelerations, which we haven't yet evaluated, but will be part of the next release of work regarding this benchmark moving forward. Some of the features of PyMC-Marketing are neat, and it's worth calling out. PyMC-Marketing allows for not only using a time-varying intercept, but also for a time-varying coefficients. That means that your media effects, if you want to, in the most complex models, can be actually a function of time. And this allows to measure, for example, changes in efficiency of channel. And PyMC-Marketing has multiple sampling backends. We see this as actually a key advantage that emerged during the benchmark. And the other key point here is, if you go a little bit up, please, Jake, a little bit up, that PyMC-Marketing here has very easy ability to do auto-sample forecasting, while Meridian can do auto-sample forecasting by hacking it around using a validation set, using the validation functionality, but they actually do not support it natively in the API. So now, keeping in mind these high-level differences, both libraries are actually extremely helpful tools, and they have made to the community the ability to write actually relatively complex media mix models with hierarchical components, time-varying intercepts, and things like diminishing return and add stocks, relatively easily task for data scientists. The last thing that is worth calling is the companies behind these two libraries. PyMC Labs is a consulting company that's built around the open source frameworks of PyMC. We work with clients to use PyMC-Marketing as the backbone to implement the most advanced media mix models, guiding internal teams on the implementations. While, of course, Meridian is built by the Google team, who's a large publisher and network, and of course is interested in us spending the most possible in media and advertising. In fact, one of the key differences here that it's also worth calling out is that recently PyMC-Marketing includes this database schema integration, which means that you can, via a partnership with Fivetran, if you're using Fivetran, get all channels and media ready for media mix modeling with just a few lines of code and a few clicks, while Meridian generally is really well integrated with the Google ecosystem. So there is syntactic sugars and there are APIs to getting your data out of your BigQuery if you are a Google user. Now, moving from the high level into the details here, so if you go to the next, the focus of this benchmark is going to have some scientific quantitative rigor, because really, like most of the evaluations we've seen in the industry, they really just focus on comparing the high-level features of the two libraries that are relatively similar with each other. And so there is an empirical gap regarding things that are extremely important to develop a library, which is runtime, accuracy, and convergence of this algorithm. And we think that this is extremely important to form informed choices. And so informed choices that will guide your technical development. And the way we are going to do that is we're going to use a typical framework of evaluating Bayesian models, which means we generate some data that we know exactly constructed with specific parameters so that we can know what is the ground truth media contributions of these data sets. And of course, some assumption goes into the construction of this data set. We think it's realistic assumptions because this is representative of our experience of working with dozens of clients on a lot of different media mix models implementation. And so we have seen a lot of marketing data at end. And then using these data sets of different sizes, representative of the clients we have, we can fit these models in turn and evaluate how they reconstruct these underlying media contributions and how fast are they in making a fit for these models. And that's what we're going to talk about next. So I'm going to lead it to Jake that's going to talk about the details of these evaluations and the results.
Thank you, Luca. So before deep diving into the findings, we're going to explore a little bit about the data generating process and the model specification and overall structure between the PyMC-Marketing model and the Meridian model. So regarding the data generation, this was designed to have configurable parameters to allow us to easily and flexibly modify the number of channels, geos, controls. And the realistic media patterns we see in this data set are derived using a modified AR2 process, which was particularly good at simulating momentum and promotional spikes. And obviously, when generating this data, in order to compare the true versus predicted contributions, we're going to want to store the ground truth values. You'll probably notice, if you've explored the repo, that we have various presets in this in the data generation, and these are the presets that we're going to be exploring throughout this webinar. And these presets are defined based on MMMs that we've worked on at PyMC Labs and realistic data sizes of clients we have. So a little bit on the workflow. So in order to set the data up, the first thing we're going to want to do is configure the baseline sales and define the level of seasonal variation we want between our geos. We then want to define our channel and control patterns. Now, this is a particularly important element of the data generating process, purely because in realistic MMM data, we often do have seasonal marketing spends, seasonal marketing impressions. We often see various different variables with linear growth or linear decay. There are on and off channels, so not all channels are permanently on. Some may be switched on at certain times in the year or activated for a given campaign. And as some of us may know, in MMM, we require 2 to 3 years of data. There may be channels that have been activated within that window and haven't been activated for the whole duration. So we do want to configure some channels to have a delayed start there as well. Once we define our patterns, we then want to define our media transformations, and this is simply add stock and saturation. I believe these are configurable, but for the comparison, we have used a geometric add stock and a hill saturation. We then want to choose the number of regions and our hierarchical effects. So the baseline, the control parameters, and the transformation parameters are all being generated using a global mean. And once we have all that configured, we can simply generate our data set, save off the ground truth values, and start off with analysis. So as I mentioned, the presets, these presets are based on the different kind of levels and scales of businesses we've worked with. And we can see we have 4 different presets. So we have the startup, the growth, the mature, and the enterprise. We can see that these data set sizes grow quite rapidly, especially the enterprise data set. This is a really big data set. The startup is only 1 geo. So this is a typical national model example. And then any data set after the startup is multidimensional, has multiple geos. And we have multiple examples of companies which may have data sets that size. So now we've covered the data generating, we're going to talk a little bit about the model specification for both the PyMC-Marketing model and the Meridian. There are some key points to explore. So for both models, we primarily utilize the default prior distributions. There were a couple of exceptions. So those exceptions are the saturation parameters. Both saturation parameters for both models obey a hierarchical structure, and the add stock parameter for the Meridian model. That was purely tuned because the default in Meridian was quite a flat prior, and we encountered various issues when using that. So we tweaked that to align with PyMC-Marketing and to improve the sampling efficiency and fit of the Meridian model. The most important key point, which we are going to touch on a bit later as well, is the seasonal approximation. So for the Meridian model, we've used a 26-week NOTS to approximate the seasonal behavior, as unlike in PyMC-Marketing, Meridian does not support Fourier seasonality directly. And we've informed our media coefficients using spend share, which is a pretty common practice in MMM, as it helps give us sound foundations for our prior predictor. So let's dive into the maths. So for PyMC-Marketing, we can see we're modeling at geo level over time. We have a constant intercept per geo, so there's no time varying elements going on here. This part of the model specification defines our Fourier seasonality, and we can see here we have Fourier seasonality of order 2. So this is 4 different sums because we have 2 sine waves and 2 cosine waves. We have a control element of our model, and we can see here this big section represents our media, and our media is adstocked, which is parameterized by alpha, which is the decay rate, and it's then passed through the Hill saturation with parameters lambda, beta, and sigma. It's probably worth pointing out that the sigma parameter in the Hill saturation, although it is innate to that saturation function, because it controls the ceiling of the saturation curve, it's also used to represent the media coefficient here. So it's this parameter that has been informed by the spend shares, and this parameter that also has the hierarchical pariah. When we compare this with Meridian specification, we see there are lots of similarities, but also some differences. So these key differences are the intercept here, which we can see varies over time. So this represents the knots and splines approach that Meridian has to capturing seasonality. Obviously, there's no Fourier term, as in the Meridian model, that is the substitute for the Fourier term. Just like in PyMC-Marketing, we have intercepts that vary by geo. We have the channel control element, which is the same. And you'll notice the media looks very similar, but the parameters are labeled slightly differently. And the reason for that is that the PyMC-Marketing parameterization of the Hill function is slightly different to the Meridian parameterization of the Hill function. It's the same saturation function, they're just written in slightly different ways. And it's probably worth noting that just like in the PyMC-Marketing model, we have a hierarchical pariah, and the priors are informed using spend share for the media. But for the controls, we have a hierarchical pariah for the Meridian model. This is left in this model purely because we want to use the Meridian model with as much as we can default. It's also worth pointing out as well that this is really, it kind of mimics the way in which we've generated our control data in the data generating process as well. So now we have our model specifications. It's always interesting to check before we commence any modeling how many parameters each model has. Obviously, as we expect, we increase our dataset complexity, the number of parameters increases. But we can see across all datasets here that Meridian does actually use more parameters than what we use in PyMC-Marketing. So before any fitting is done or anything of the sort, this may imply that the Meridian model may be more flexible. Now, I said I was going to return to the Fourier seasonality versus splines argument. So there are 2 distinct approaches for capturing seasonality, and they are fundamentally different. So that's why this is probably the biggest key difference in the model specifications. So Fourier seasonality, which is what PyMC-Marketing uses, essentially models periodic patterns as a sum of cosine and sine functions. And this is excellent for modeling sort of repeated cyclic seasonal effects. However, when the seasonal effects are not sort of repeated every year, and then they don't follow that sort of repeated cyclic effect, what one would usually do is try and increase the number of Fourier orders to try and capture this irregular complex seasonal pattern, and that can often lead to overfitting. So Fourier seasonality generally doesn't generalize well to those seasonal patterns. Splines, on the other hand, generalize really well to irregular seasonal patterns, but not so much to the type of seasonality that Fourier seasonality generalizes well to. And again, probably the biggest limitation of splines is that it does not support extrapolation for outsample prediction, as Luca mentioned when looking at the features. So let's move on to the findings. So within this benchmark, we've explored technically four different areas. We've looked at computational efficiency, predictive performance, so how well we recover our target variable, and channel contribution recovery. So how well we're recovering the true channel contributions. And towards the end of this presentation, we've also touched slightly on memory usage as well. So when looking at computational performance, I just want to point out that looking at runtime alone can often be misleading, especially if your sampling quality is poor. So in order to accurately compare computational performance, what we're looking at is effective sample size per second. And in a nutshell, a higher effective sample size per second indicates a more efficient, reliable estimation. So here are the results. So we can see for the startup dataset that the PyMC-Marketing model with a NumPyro sampler has the highest effective sample size per second. And as we start to expand our datasets, so we look at the scale up, the mature, and the enterprise, we can see that the PyMC-Marketing model still is the most efficient model, but the choice of sampler has changed to the NumPy. And this really highlights, as Luca mentioned earlier, the benefit of easily being able to switch out your sampler based on such circumstances you're in. So for the startup data set, this was one geo, and then scale up onwards, we're working with multiple geos. I'd also like to point out that although the Meridian model didn't sample successfully for the enterprise data set, the PyMC-Marketing models didn't sample amazingly. And I think the reason for this is that the enterprise data set realistically isn't something that we would want to use sort of an off-the-shelf default version of PyMC-Marketing for. With this type of data set, we would want to introduce GPU power as well, but we would also want to perhaps do something a bit more custom for this. But overall, the PyMC-Marketing models did sample. So besides computational efficiency, we looked at predictive performance. So we can see the plots on the left-hand side. There's two plots here. There's one for the PyMC-Marketing recovery, and there's one for the Meridian recovery. In both plots, the black line represents our target variable. So this is actual sales. The blue line in the top plot represents the PyMC-Marketing point estimate. So this is the point estimate predictions. And the yellow in the bottom plot represents the same point estimate prediction for Meridian. You might not be able to see too well on the yellow plot, but on the blue plot, you can probably see there's a shaded region surrounding the point estimate prediction. And this is the HDI. So what can we take away from this? So when looking at the top plot, we can see that the PyMC-Marketing model does a really, really good job of predicting sales here. And what's really important to observe is that the actual sales, so the black line, is contained within the HDI almost all the time. This is a really good indicator that we have really, really good prediction. When we look at the bottom plot, you probably can't see the HDI as well, but we can see straight off the bat that prediction isn't as successful as above. This may indicate a misspecification in the model, something of the sort. But yeah, there are lots of regions, especially around here and around here, where predictive performance is quite poor. Yeah, this is a snapshot for one geo as well. So what we're going to want to do is sort of summarize how well predictive performance is across multiple geos. And to do that, we're going to look at three different statistics. So these statistics are the R-squared, which measures the proportion of variance in the observed data that is explained by the model, the MAPE, which is the mean absolute percentage error, and the Durbin-Watson, which is a statistic to detect the autocorrelation in your residuals. To interpret these, we want an R-squared that is close to 1, we want a MAPE that is really, really low, and we want our Durbin-Watson to be close to 2. So to generate these results, we have averaged across geos. Obviously for the startup, that doesn't count, but for the remaining data sets, we took an average across the geos. Now, if we take a look at the R-squared, specifically for the startup data set, we can see the point estimate is greater than what we see for Meridian. And you'll probably notice there's an upper and lower bound to this R-squared, and that's because we've calculated the R-squared based on the entire posterior as well, not just the point estimate. And we can see that when we look at the HDI of our R-squared, the Google Meridian HDI is actually sits outside of our PyMC-Marketing R-squared, indicating that there is a significant difference in the R-squared metric. And the same can be said when we look at the mature data set as well. For the scale up, there is a slightly different pattern going on here. We see that the models are actually behaving relatively similar and predicting, well, the R-squareds in general are quite similar to and close to each other. We see a similar sort of story for the MAPEs, where in the startup, we have much higher MAPEs, much lower MAPEs for the PyMC-Marketing model, and in the mature. But in the scale up, again, these MAPEs are really, really close to each other. So that may well imply that the Google Meridian model works a lot nicer when we have geos as opposed to for just one national model, which is what we see here. Now, the most important observation is probably the Durbin-Watson. So as we mentioned, we want a Durbin-Watson close to 2. And we can see that for the Meridian model, our Durbin-Watson is really, really low. So this tells us that we have positive autocorrelation in our residuals, which is a really, really good indicator that there may be a variable or an underlying process missing within our model, which we was a bit surprised to learn, purely because both models are trained on the same data set. They all have the same information. And obviously the Meridian model has more parameters as well, so that was quite surprising to learn. We do believe that these results are coming from the difference in how the seasonality is being modeled. So we don't have the figures here, but we did run some simulations where we repeated this by increasing the knots in the Meridian model multiple times. And we saw that although, yes, predicted performance did increase as predicted, the Durbin-Watsons were still significantly lower than what we observed in PyMC-Marketing. And yeah, if you have access to the repo, you can go ahead and try this yourself and yeah, see what results we find. We can also see the same has happened when we don't average across geos. We have a consistent pattern going on here. So obviously, predictive accuracy is very important, but one of the key features in MMM is being able to allocate contribution to our channels. So next, we're going to explore the channel contribution recovery. So we can see the image here is a snapshot for one geo of 2 different channels. And just like how we interpreted the predictive accuracy plot, we can see the actual is the black line and the predicted is the blue and yellow line. There are HDIs surrounding both. So if we consider the top channel here, we can see that the PyMC-Marketing model for this particular geo and that particular channel does recover the contribution slightly better. And what's also an important observation is that we're on the peaks, we're slightly over predicting in PyMC-Marketing and slightly under predicting in Meridian. That may well imply that the estimate of the saturation ceiling could be very different between both models. Yeah. And if we look at the channel below, we can see that the Meridian model is struggling to capture the peaks. This is more of an on-off channel. We can see that the Meridian model is struggling to capture the peaks here. So again, that may well imply that there are some differences in how the models are estimating the saturation ceiling effects. But just like we did for predictive accuracy, we're going to want to summarize this across geos, across channels. And to do that, we're looking at 2 main statistics. So the first statistic we're going to look at is a measure of bias, which is just the reconstruction error. So that's the observed minus the predicted, averaged over time. And to infer on accuracy, we're going to look at the scaled RMSE. Now, there are 2 reasons why we've opted for this statistic. The first reason being that this statistic can be interpreted really nicely. Because it's scaled, it can be expressed as a percentage. So it has that benefit in interpretation, similar to what we would get for calculating the MAPE. The other benefit is that the scaled RMSE behaves really well for channels where we have lots of zeros, or contributions, sorry, where there are lots of zeros there. So it's more of a robust metric. So those are our reasonings for choosing those. And just like we did for predictive accuracy, we have averaged over the geos, but we've also averaged over the channels here to provide an overall statistic. So there are a few observations we can take away here. So let's consider the bias first. So when we look at the bias for PyMC-Marketing, you can see that our point estimate is consistently negative, indicating that we are actually under-predicting on average across geos and channels. For Meridian, the pattern isn't consistent, so that does imply that for Meridian there's some over-prediction and some under-prediction, but the absolute value of the point estimate is much smaller for PyMC-Marketing across the board. So that's an indication that the predictions, like we saw in the plot, which showed one channel across one geo, are less biased. We can also look at the HDIs here. We can see that for the PyMC-Marketing model, our HDIs are actually smaller across the board. When looking at the scaled RMSE, we can see that the PyMC-Marketing model actually gives more accurate contribution estimates, and also the width of the HDI is much smaller as well. So that indicates that not only are the contribution estimates for this model more accurate, we're also more certain in our predictions as well. Now, you'll probably notice the enterprise level data set looks quite strange, especially for the scaled RMSE. And the reason for this is, if you recall, when we looked at computational efficiency, the sampling quality was quite poor. So this scaled RMSE is skewed by a small number of channel geo combinations in that calculation. But as we mentioned before, a data set of this size would usually require some sort of custom modeling. So here we see another snippet for another channel. I think this channel is quite an important one to look at because this is a on-off channel. The top chart shows the raw input, so this would be the spend pattern. And we can see we go through periods of time where we're spending, periods of time where we're not spending. So this might represent, like a seasonal campaign or something. The plot underneath shows the black line shows the actual contribution. The yellow and the blue show Meridian and PyMC-Marketing respectively. And this just so happens to be a channel where PyMC-Marketing is under-predicting and Meridian is actually over-predicting. But one of the key takeaways from this is we can actually observe the ad stock effects that's going on here. So if we look at this period in particular, we can see the spend stops around there, which is aligned with the peak of the contribution here. And if we look at the tail here, which represents the lagging or ad stock effect, we can see that in the PyMC-Marketing model, the ad stock effect better fits to the true ad stock effect that we see in the Meridian, that we see in the actual contribution. So that's a really good indicator that the PyMC-Marketing model might be doing a better job at sampling the decay rate as well. And then the plot below shows us our prediction errors over time. And we can see that for Meridian, the heights of these prediction errors most of the time align with the ad stock effects that are going on. So where there's no spend. And lastly, I did mention this part would be brief because we plan to expand on it, but memory requirements. So to infer our memory requirement, we looked at a model building and sampling memory requirements, and we looked at the size of the fitted MMM object. So when sampling, we saw that the PyMC-Marketing model required about half as much memory as what the Meridian model did. I would also like to point out that when sampling these two models, 4 chains were used, and these chains were sampled in parallel. When we look at the size of the MMM object, we can see that the PyMC-Marketing object is far bigger than the Meridian object, but this didn't come as a surprise. The PyMC-Marketing model object does store the data by default, so that's going to really inflate the size of the object. And that about summarizes findings. So I'm going to hand you back over to Luca.
So thank you very much, Jake. So we went through a lot of material, and we wanted to leave enough time to you to answer any questions. And I see. Thank you for the great questions that I see already in the channels. I'm gonna try to address them in a minute live, the ones that are remaining, and feel free to ask more. I wanted to take just a few minutes to wrap up what the business implications are of what we have seen today. So I think there are 4 key points to bring on. First, PyMC-Marketing and to some extent Meridians are both excellent tool to get to a rapid implementation to a media mix model with very minimal customization. In fact, we have seen that in the spirit of the benchmark was to leave as much as possible defaults in the 2 libraries. We made the few modifications to the defaults parameters and to the default structure of the models to align them as close as possible. But cannot be done to 100% because the functional forms are different. And so we took the perspective of a data scientist that wants to use the libraries as it is almost out of the box. So if you do that, both libraries give you a good tool to build simplified media mix models really effectively. PyMC-Marketing achieve faster iteration cycles by matching the best sampler options as the complexity of the dataset scales. So one of the advantages of this library is that because you have different sampling engines behind the hoods, and some of them, they use really advanced and sophisticated algorithms, you can really scale also with little effort to pretty large datasets for the enterprise. And on small that relatively limited data, you can get this up to 20x the speed, which allows you as a data scientist to play with these models way, way, way faster. On the other hand, we saw that the ability to have off-the-shelf, out-of-the-box, this Fourier component is probably what led to a higher reconstruction accuracy for PyMC-Marketing. And we do think that this allows you for more reliable decision making. Of course, if you build a very custom implementation, you could try to do the same with Meridian. But the point is that the API allows you to do that off the shelf in PyMC-Marketing. And then the last point is that I believe especially PyMC-Marketing, because of this very flexible API, the ability to have time-varying intercept and coefficients, the ability to create any kind of priors that you would like, and combine them easily in hierarchical structures, really allows you the flexibility to scale with the complexity of your business. And you have the numerical engine behind it to fit these very complex models up to very large data sets. So this we see with some of our clients that, for example, have the scale of models that have hundreds of thousands of parameters that really requires days to fit on a GPU. So I hope you found this interesting. Happy to answer with the team any of your questions right now. And I'm going to go through a few of them that have been left open. So what is, do you have any theory to holistically explain PyMC's superiority in performance with respect to accuracy? Do you think PyMC would remain superior on real industry data? So these are questions from Julia, very good questions. We do think that the dataset is representative of real industry data and what we see with our clients, like really indistinguishable from what we see from our clients. The theory here is that the functional forms of the model has to do part with it. The fact that we write our hill functions in a way that's parameterized for efficiency help the sampler. The fact that we have a Fourier seasonality, and this is a data set that does have periodic components and dependencies that help also the reconstruction error. So these are the main reasons. Notice that there has been some discussion online that we have seen with people arguing that you could have increased the number of knots in Meridian's splice implementation to try to get a better fit. And we actually did that experiment. We tried different configurations for the knots. We also tried different numbers of Fourier's modes for PyMC marketing. Overall, the results didn't change that much. Actually, when you increase the number of knots for meridians, what we saw is that these, if you go to very extreme values, like the defaults, you get error in convergence, especially for the very large data sets. So our perspective here on this problem is it really doesn't change the insights of this benchmark, and you could do that adjustments to get more or less to the same conclusions. It's simply that Fourier seasonality is a better tool when you have a strong assumptions that there is periodic like effects, periodic impacts in your marketing mix, which is a reasonable assumption. And of course, it's one way to model seasonalities, but also like it's the natural way of modeling seasonality. It would be hard to imagine a data set that's constructed in a different way. Other question. Maybe Timo, do you want to pick one so I can flip through the others?
I'll mention there's one that's upvoted here, and for those of you who have asked questions, or if you see questions that you're particularly interested in, feel free to use the thumbs up icon so we can see the most in-demand questions. And there's one for William at the top here. That's, could you share the recommendation for designing and integrating a nested model, such as for the contribution of indirect branding effects?
Really good question. We have tons of clients that actually come to us with a similar question. There is a lot of nuance that goes into this. In fact, I would be taking probably too much time of this call to go into all of them. What I will point you out to is feel free to reach out to us via our mailing lists and our website contact form to learn more. On our blog post, we regularly post like insights on how you build media mix models and our advanced models using PyMC and PyMC marketing. So we will publish actually a blog specifically about modeling branding effects. Generally speaking, also maybe media mix modeling, not the right framework to do that. In fact, we are thinking about another framework, which is Bayesian variational models, or Varmax models, that's actually more appropriate to capture very long-term effects. We know that ad stock can easily capture up to, let's say, a few months of delayed effects, but they really fail to capture very long effects. And typically what also happens is that when you have strong branding effects, you have a two-step effect where there is an immediate ad stock given by the response of the channel and a longer term one. And this mixer tends to throw off the fit of the models in itself. So long story short, to learn more, like please do reach out to us in our mailing list.
I think there are other questions also on the same line. On, for example, there's the question about indirect effects on media that first increase the volume in web sessions and then later on indirectly drive sales, which is kind of the same phenomena. There's also, you will find, like Luca said, the challenge is these very long ad stocks and decays. If this is a reasonable length ad stock, say a couple of months, then you will find a really recent discussion in the GitHub side of PyMC marketing. There's the discussions in the GitHub, and we discuss funnel elements there, how you would like them to see them in PyMC marketing. So if you have opinions, I invite you to also jump in there. I'm very interested in seeing those in PyMC marketing in the future. So input is very welcome.
Yeah, and maybe Timo here is actually a good time to mention the mu effects in PyMC-Marketing. That's another implementation of the PyMC-Marketing library that allows you to build mediation models very quickly that would have a funnel implemented. And maybe you can speak to that as well.
Yes, I've been answering that to a couple of questions also on writing, but yes. So in PyMC-Marketing, for most of these questions, I've said as an answer the mu effect. So which is this very flexible protocol which allows you to add an additive custom component into your model where you can add more complex interactions. For example, interaction between two channels. So if you have media spent on two channels and how these interact with each other, a mu effect allows you to define this as a PyMC through the PyMC components and then return that to the model so that gets added to your predicted sales. Or you can also, for example, do this mediation where your marketing activity on an upper funnel awareness channel starts affecting your searches, and then you get then more activity on the paid search channels. So this is another very good use of these mu effects.
So there is a question regarding how PyMC will behave with disruption in the company, such as a strike from employees, so the company is unable to provide a service.
This sounds like an event. Yeah.
I'm wondering if this is referred to as a problem in our consulting services or in the company historical data that we do see. And the question is, I mean, the point is that PyMC Labs has existed for the past 5 years. It's going to continue to exist. PyMC-Marketing is a very actively developed library. So we'll continue supporting that forever. It's a thriving business indeed. And if this refers to the historical data, well, it's not the problem specifically of PyMC. It's a problem of any modeling approach based on historical data. If you've never seen that event, it's really hard to model or to infer what will happen in the future. And here you will need to add a few assumptions. For example, you can do that in a principal way by changing the priors that you have, because you have some assumption that the data in the future will look different. Or you can build some kind of downstream corrections to the models. For example, I can speak to my experience of HelloFresh, where we went through the COVID period. We, of course, had a lot of trust on our media mix models, historical data and performance. But generally speaking, we couldn't trust it during the first periods of COVID. And so what we did is a couple of things. First is you really correct the results of the model with some top-line assumptions. Generally speaking, we weren't spending that much in marketing during that period neither, because we had a lot of organic inflows of customers. And after the beginning of the period of COVID stabilized, what we actually did was refit that model very, very often and give a weight to the most recent data, so that we would bias the model based on most recent performance. So these are some of the tricks you can do to account for that. Any particular link to understand how to create a model with mediator variables like TV, search, revenue? Yeah, again, we will publish a blog post regarding that. Feel free to reach out to us on Discord or via the info@pymclabs.com. The mu effect is the correct way of implementing it. It's part of the API of PyMC-Marketing. There isn't much documentation, to be fair, about that yet. We will provide a lot more documentations, but it's actually a relatively easily implementation in terms of code, although there is a lot of thinking that needs to go on which effects you need to model.
A very similar answer for this incorporating organic data, which is not paid channel or not necessarily a control. For example, you would often want to have some kind of saturation or ad stocks on those, even though it's not strictly a paid media channel. And again, my solution would be the mu effect. So essentially, you are creating a separate effect for those that then is not part of the optimization. So you don't get like the budget optimizer trying to assign budgets for these parts. I think we should be giving an example in our examples gallery for this kind of implementation in the near future. It's a highly requested feature, which technically is already possible.
Timo, do you have a weekend project for this weekend? Can we apply PyMC marketing at campaign level using 3-4 years of historical data? I mean, big campaign focus on a specific product running 2 quarters with a long sustained tail every year. Generally, yes. I mean, there is a lot of like nuance that get into that, and I would have to ask her a lot of follow-up questions regarding the shape really of these data sets and what gets into it. But generally speaking, we do have some of our clients that are using PyMC marketing to model campaign level media effects. So it's totally possible to do, and actually a very effective way of doing it.
I want to do a quick time check. We've got just a couple minutes left in the webinar. Maybe we'll pick one final question to answer live. And then a reminder, I just added a link there in the chat to the Bayesian Discord, where we'll post all of these answers, and we'll continue answering questions, any questions that you have about the webinar. So invite people to please go there. And I also put a link to the code. So if you want to jump into the code and look for any specifics, it's there and will be updated regularly. But Luca or Timo or Jake, do you want to take the last couple minutes to pick one last question that's on here to answer?
I will pick this question from G Gao. Thank you for the session. If you want to use this comparison framework for real data, does it make sense to use the actual media data input, but with simulated parameters, and evaluate how well it recovered? I would say that it's certainly possible to do. I'm not sure why you would get different results if you just use the spend as an input. I mean, the spend level, if you look at the actual data set we have created, which it's all the code, source code is available, is very representative. So it's kind of hard to me to imagine why you would get a very different result. However, it's certainly possible to do. And to me, this is an opportunity also to remind that we made this benchmark open source because we want people to contribute. So feel free to send us pull requests, feel free to send us comment, open tickets, and help us develop further this framework. For example, one thing that we are actively developing right now is a comparison on a GPU between these 2 libraries. As every insight you've seen today was CPU based.
Perfect. Luca, thank you so much. Timo, Jake, thanks for sharing the great work that you guys have done today. Everyone who attended, thank you so much for coming. We hope it was helpful. We really appreciate the strong engagement. There are a lot of questions. We hope they got answered. One last reminder that if you missed an answer or you weren't able to copy paste it fast enough, it will be in the Bayesian Discord, which is linked in the chat here. The recording will be available. The soonest place to find it will be on the LinkedIn live session, which I just dropped a link there. But for anyone who attended the meetup event, you'll be directed to the recording. If you have any questions about anything here, feel free to reach out to any of us from the PyMC Labs team. You can find us on the website or on the Discord is great. Thanks so much, everybody, for coming. Thanks to the panelists for the insightful work here. And we'll see you at the next webinar.
Bye-bye.
Thank you.